Go.
Hello, my name is D'Angelo Jackson. I'm a senior in Earth Science at GAT. We had Chapter 4, Plate Tectonics. It reads as follows. In 1912, a German scientist, Albert Weger, proposed a hypothesis called Continental Drift. The state that continent has moons, Weger had hypothesized that the continents once formed one part of a single landmass, which he named Pangaea, which means all land. Surrounding Pangaea was a huge ocean about 200 million years ago. Pangaea began to break up into smaller continents, which drifted to their present location. Mid-Atlantic Ridge is an undersea mountain range with a steep, narrow valley running down its center. Robert Detailles named the movement called seafloor spreading. It shows how the ocean floor moved away from either side of the ocean mid-ridge. Plate tectonics doesn't only describe continental movement, but also propose a possible explanation. The Earth crust consists of two types of ocean crust and continental crust. The material on the ocean floor forms oceanic crust. Continental crust makes up the continental landmass. The oceanic and the continental crust and the ridge of the upper mantle makes up the lithosphere. And under the lithosphere lies the asthenosphere, which means a layer of plastic rocks that is solid rocks that slowly flows when under pressure. Divergent boundary is when two plates move apart from each other. When the plates move, molten rocks cool, then it hardens onto the edge of the separating plates to create a new oceanic crust. Convergent boundary is which forms a direct conclusion of two lithosphere plates. Transform fault boundary forms where two plates are grinding past each other. A major transport boundary is in San Andreas Fault in California. Convection is the transfer of heat through movement of heat fluid material. The cycle of warm water rising and cooling water sinking to a place is called convection current. My name is Thomas Haynes, Jr. at Garrett. My article is on ancient continentals open windows on the early Earth. It talks about the banks of the Augusta River, deep in the barriers of Canada, Northwest Territories, stands a lonely shade. There is no sign of humanity for many miles, just low hills and few black spirits, a thick cover, reindeer moss, and endless section of lakes and rivers. The only way to get here is by a canoe or by a float plane. But this shed filled with geologists' hammers, boats, and camping gear marks a special place over the door of the blank on which some has painted Augusta City Hall, founded for GA. It commemorates the surrounding rocks, some of which are over 4 billion years old, the oldest rock on Earth. Geologists first recognized the quality of the Augusta region in the early 1980s, but at the time it wasn't clear whether in the oldest rocks could say much about Earth's early history. Much of the ancient landmass which rocks belongs had been remelted, burned in the mantle. Now the researchers have started to publish their results in several journals, including special issues of Canada Journal of Earth Science, July 1999, and Geoscience Canada, March 1998. They report that they have placed the Augusta rocks within the relative large procontinent. What's more, they can trace the history of the continental nuclear for 1.5 billion years after its began 4 billion years ago. The incredible longevity of history in the area is mind-blowing, even for a geologist. Say its turn. And that will be on our poster. Right here. So, just picture that on the poster.
What's the top picture showing us?
This right here is our Divergent Boundary, and this is our Convergent Boundary, and you know, got the manual, need this bit, got the shift.
What about that one on the left? What does that show?
Oh, this is that's the little experiments, plates. It shows the different plates in the different areas. All the different plates in the in the worldwide. And that's it.
All right.